Good afternoon, thanks for coming. So we're going to do three short presentations about this building. Just as means of introduction, my name's Tom Emerson. I'm one of the founding directors of 6A Architects. We're based in central London. About 35 people, mainly working in arts and education. And we've been working for a very, very long time with Price & Myers, with Paul, for about 15 years. And then Cowan Court was the first project we've done with Adam and SDC. We won the competition for Cowan Court in 2008. In fact, it wasn't called Cowan Court, it wasn't even a court. It was a competition for student halls of residence in Churchill College. But many centuries before that, so at the beginning of mythical time, somebody had done this project, the Garden of Eden, which is essentially the idea of the walled garden. And inside the walled garden, you have the tree of knowledge, you have the crossing rivers, and outside you have all the wild beasts, all the wilderness, and all the danger. And that was really the model that became the cloister. So I'm going very, very fast. In particularly Romanesque medieval times, became the monastery cloister, which then, a few hundred years later, became the court, or the quad if you're in Oxford. This was the building block of the kind of university, or at least the Oxbridge model. This is the centre of Cambridge. You can see King's College, Trinity, St John's, the real kind of classic courts. And then northwest of the city centre, there is Churchill College, which was built in the early 60s, part of the kind of post-war expansion of the university system. And it also used the court system. So it's a series of 10 courtyards around Churchill's archive. And so this type, that let's say from the Garden of Eden to the kind of 60s brutalism, is essentially kind of endures. And it's essentially a landscape structure. This is actually the centre of Cambridge. So if you were thinking that Cambridge is actually a city, this is by the Mill pub. Cows, ping pong, weeping willows. Churchill College, early 60s, designed by Shepherd Robson, Richard Shepherd. It's one of the best examples of a kind of English brutalism in brick, Staffordshire brick, and concrete. With a very, very strong landscape integration. These trees which were planted at the same time as the building of the college, the willow, walnut tree, and so on. And then one of the characteristics of brutalism is, you could say, a kind of slightly overly expressed structure. These kind of quite muscular concrete elements with big downstand beams and so on that give a kind of sculptural expression to the college. So this is the original courts, and our project, and we were the only ones doing the competition to, the site is here, to actually propose a court building, which to us seemed like a no-brainer, but maybe that's why we won. So we essentially continued the tradition and said, okay, we will do another court. In fact, but what we will do is fill it full of trees. So our building is actually in an open landscape, so it's surrounded by playing fields, tennis courts, cricket fields. And so we would bring the landscape within it, so almost inverse this kind of Garden of Eden thing. This is Anglesey Abbey near Cambridge, where there's a birch forest in the centre of a court. So the original college, court, and Cowan Court essentially is the same in plan, but then reorganised, as I'll explain, with all the bedrooms around the outside because of the views, the surrounding landscape, and all the common parts around the inside. The main difference, apart from the organisational one, is if the original buildings are all concrete and timber, or very mineral, ours would be entirely timber. So it would be completely organic. This is a section, it's a 3-storey building with an open cloister at the bottom, and then 2 stories of internal cloister. And one of the inspirations was also Paycock Hall in Essex, not far from Cambridge, which is, I think, one of the finest timber frame buildings in the UK, particularly for the jettying out of one floor over the next, which is very typical of kind of medieval thing. So ours also then has this kind of cut which then projects each floor out onto the next, and also reflects the banding of the concrete banding. It's made entirely out of timber, and the cladding is reclaimed French oak from railways, but I'll come on to that in just a second. Organisationally, the original courts, and many of the ones in Cambridge, not just Churchill, are organised around staircases, so lots of vertical clusters of rooms. Of course, you can't do that now because of accessibility requirements, quite rightly. So we, in fact, based it more around a horizontal cloister than a vertical stack, which would be typical of the older colleges. It's made entirely out of a timber frame for the 4 wings, but as you'll see in Adam's talk, then in order to build it, there was some adjustments made, particularly around the staircases, to optimize the building process, but I'll leave that for Adam to describe. 2 staircases, 1 lift, and 1 lift well, so there could be a second lift installed if they need it. Of course, the thing that became really interesting when we said we wanted to do a building in the opposite of concrete, we would do it in timber. Concrete actually used to be timber anyway, so there is a sort of, it's kind of different to a concrete building, but it's also very similar in texture. And these are the various samples of the reclaimed oak, which came from railway carriages, freight trains, the beds of freight trains in France. It was found in Brittany, a place called BCA, and they had 8,000 square meters of it, which the college very bravely bought, but even before we went to tender, or at least put a deposit on. And then it was applied onto the building through a series of kind of prefabricated panels, then with end panels sort of closing the gaps. And some nice visitors, exactly the same color as the building, their little down ducks. The inside of the building is new oak, so then it's like a sort of, the inside is really, really sort of sharp. It's almost like cutting a fruit, where you have this kind of rough husk and a very fresh inside. And then other motifs from the college, that's the gate on the left-hand side, cast aluminium sculptural gate, that then we use as the form for the frieze at the top of the building. And then also part of this kind of idea of this curve that somehow makes the building more into a kind of landscape structure. This is the building in front of the copper beech tree in autumn, where it almost blends completely with its landscape setting. The bedrooms, which have window seats and oak casements, this is one of them lived in. Corner rooms, which have 2 windows, which are really kind of quite spectacular. And then this is the sort of the building just when it's finished, with this almost regular facade of windows with slightly step, but then get rearranged around corners to bunch windows together. The inside, as I said, is kind of new oak with these kind of big downpipes at the center of each facade. And then the staircase, which is concrete, but made of very similar section sizes to the to the timber and the concrete, so they become almost like indistinguishable. There you can see the kind of timber, concrete, so they almost become like one becomes the repair of the other. And then I'm going to pass on to Paul at this point to talk about the structure, because one of the things we wanted to do was to bring back out in timber, let's say, some of the motifs that had been made in concrete, which had been made in timber. So it's this kind of constant cycle of materials substituting for one another. But before I sort of make too much of an amateurish description of structural performance, maybe I better pass it over to an engineer. Thank you.
Right. Good afternoon. As Tom said, we've been involved in this project from the very beginning. We were involved at the stage of the kind of competition. And really what I want to say a lot is about the kind of process of going from that idea to the completed building. and how during that process we kind of kept all of the main principles intact. So here's the original kind of competition sketch, which shows a sort of slightly different building. There were, at competition stage, the thought of more staircases than we ended up with. But effectively, really the same concept of cross-section which stayed throughout. 3 stories. Yes, it is just about all kind of timber. There are the sneaky things of having a kind of concrete ground floor and the little bits of kind of concrete around the stairs. But the timber spans from the perimeter to the inside facade. So during design development, we did look at various different ways of using timber for this project. It certainly appeared as if one might be able to use it with cross-laminated kind of timber panels, which seemed to be very good in working with the plan that was wanted, except architecturally there was this requirement to sort of reflect some of the architecture of the buildings that we were kind of replacing and to kind of show the structure. And the thing about cross-laminated timber is that it can just kind of disappear a little bit. So the alternative was to have, instead of just flat cross-laminated timber floor panels, to have beams which were exposed and that you could kind of see and immediately understand what it was that was holding the building up. As ever, of course, the difficulty with the building that looks very good at the end is you do have to have thought through all the details. And here, even at the earliest design stages, we were starting to think about how do we make sure that we coordinate the structure and the building services. So large timber beam and then a relatively shallow floor zone in which we had small timbers to kind of span between the main members, and in that zone there was then space for the heating pipework, which was the critical services item, the electricity and stuff, all fitted without difficulty. Although we did have to think about coordination with ducts as well, because this is a building with 68 bedrooms and they all have ensuite bathrooms, and they were all not on the facades and they all needed to kind of vent to somewhere. So as we worked through, we started to think about this idea of venting. Did we vent to the outside facades? Did we vent to the kind of inside courtyard? How did we make the building work as the facade stepped around on either elevation? So the outside elevation has, this square building has just 4 completely vertical corners. That jettying that Tom was describing happens on every single floor with a very gently curved facade, so that the radius changes and you have just a very small overhang at each level. But of course that's a kind of challenge for the structural engineer, because structure that's easy just goes from top to bottom in one go. So there was a fair amount of work to think about, yes, how do the kind of facades work? How do we kind of move the windows around? How do we kind of align some structure to thread our way through what looks very simple but actually requires in places a lot of paddling hard under the water to get that desired effect. This is just to say, yes, here we are. We've now kind of moved on in the design about stage C. We've definitely on to kind of large-ish glulam beams now, with the kind of thin deck small joists on top for the services zone. We've got beams above and below in the facade, which is one of the things that did vary later on in the design. But we're still very similar to that original kind of concept thought, although we are thinking more about how does everything fit together, how do we get the services in, where do the kind of ducts go, How do you organise crossovers? Can you do that just in the spaces where we can afford to have a little bit more dropped ceiling? And yes, how do we deal with changing the position of the outside wall on these big curved facades, and trying to do that without having to have anything other than straight pieces of wood, so that we have a structurally faceted facade, although the end finish is all curved. We kind of start developing that into completely kind of CADed drawings as we kind of come through, and you can then see that as you kind of work through this, there's also some added complexity in dealing with the corners. The cross section works fine almost everywhere, and then you get into a corner and it doesn't work in two directions at the same time. So you have to think of doing something else at the corners. The facades starting to kind of set themselves out, allowing the windows to do what is wanted architecturally, and to provide the mix and the variety of rooms that was at least in part a requirement of the client, to not have lots of rooms that were the same, but to have just little subtle differences, at least in lots of rooms. So yes, there is a little bit of kind of concrete in the foundations for the building, and within the staircases, where we were struggling to kind of show that we could get timber to work, as Tom said, we got concrete structure, and the size of the concrete structure was always to match whatever the timber structure was. So whatever sizes we got from the timber, that's what the kind of concrete was. The concrete was subservient to the timber. So looking now just at the kind of easy quadrant of the building, the one where there aren't any staircases, there isn't a kind of entrance into the building, just to show that there are still complexities off into the corner. How do we deal with the not being able to cantilever in two directions? Well, the secondary structure has to deal with producing the curve on the elevation where the primary structure isn't able to follow that outer curve, and also a degree of complexity around where the surfaces kind of come vertically and feed out to run around horizontally. So all pretty much the same. Interesting, trying to simplify the roof, where the roof remains pitched in one direction all the way along one elevation, all the way up the other elevation, and we simply put furrings on top of the roof to give us, to bring us back, build us back up, rather than trying to do anything complicated or put some sort of structure through on the valleys. This is tender, and the other thing about this project was that we worked all the way through, and then the project was tendered to various people, including SDC, and also who looked at different people to provide the timber frame. So this went to Ingenuity, who worked up the scheme to take all of the detailing that we'd worked quite hard on in terms of how we got the kind of facade to work, which had changed a little over time, and we got rid of beams above and below the floor and gone for a slightly bigger beam above the floor all the time, with the kind of floor hung where necessary off the edge. We resolved quite a lot of details in the kind of corners. We sorted out the fact that you needed quite a lot more structure around the inside of the building, because the cantilever effect of the bigger cantilever for the open plan space around the inner court dragged load into the middle of the building. So we'll just kind of skin through and I'd just like to kind of show you that one of the advantages then, leading into what Adam's going to say from the engineer's point of view, was how fast the building went up once we'd worked it through and Ingenuity had picked it up and developed the details. So this is September time, starting to go up. There is some steel work to do, splice connections between things. There are large bolts between columns and beams, which was a welcome change from Ingenuity in terms of how the frame was assembled. We've been showing posts aligned with beams all the way through. The big edge with beams hung from sometimes paired details, where that gives us an advantage, particularly at the wall line between two sets of bedrooms. Clever, innovative slotting connection details, which came from the contractor. This is about kind of perhaps 6 weeks after the build, and at that time when we were on site. This is really important, I think, for this kind of building. We had a kind of mock-up built to try and make sure we understood all the problems and could then make sure that we resolved the issues when we came to the finished building. So that's about 3 months, I think, watertight, so that then the facade could kind of follow on. And at that time, you'd got a almost completely finished inside room. This just shows how we'd ended up wiggling around to kind of make sure the services ran through, although part of Ingenuity's input was to decide that it was much easier to not have that joisted floor everywhere, and actually to use some relatively thin cross-laminated timber for the floor deck everywhere else, where we didn't need space for the services to be incorporated. They worked up some details to include little bits of steel in the building. And as you can see, though, their B&K Structures Ingenuity drawings really pretty much the same as ours, and we're really back to the same starting point. So we've kept the honesty of that original design really all the way through in kind of concept terms. Sizes have kind of changed a little bit, but the principles have stayed the same. And I think that's a kind of fantastic building. And now Adam's going to tell you how he managed to make it like that.
Good afternoon. My name's Adam Naggs and I'm a director of SDC Builders. We're a medium-sized building contractor based in Bedford, and a significant number of our works and projects are within the Cambridge area. We were brought along quite late into the process for Cowan Court, and the job arrived with us really as a single-stage tender, ready for the project to start on site. Our initial view of Cowan Court was one of quite a risky project. We'd received the single-stage tender, we'd started going through the information, and we were quite concerned with the complexity of the design and a lot of the risks, as we saw from a building point of view, of how we could make that building work from a quality and a time pressure. This risk and complexity then manifested itself in the cost that was put forward from us and our competitors at the tender stage of the project, and the original tender returns were quite considerably over budget for Cowan Court. So we were asked by the college to work with Tom and Paul to try and work through the design of the project, to try and value engineer the scheme, de-risk some of the elements of the design and make it cheaper and more affordable for the college going forward. So to do that, we, as I said, a lot of the risk from our point of view we saw around programme and quality, the time it would take to build the construction and work through all the different elements of the building process. So we really challenged the design concepts, not to change anything, but to look at different products and different ways of building to de-risk some of those elements of it. And I'll now run you through a few examples of that. So this is the ground floor slab that we ended up constructing on site. Originally, the ground floor slab was beam and block floor off of strip footings with dwarf walls and beam and block along the top of it. We were quite concerned about that from a building point of view, not from a longevity or structural point of view, but from a point of view of building it and the site logistics. So we, through dialogue with Paul and Tom, changed the ground floor slab construction to a raft. This gave us two benefits. One was the quickness of that construction with our ground worker, but also it gives us a very good platform to then build the frame and all the rest of the building off of. The second element that we looked at was then the cores for the building. The original building was basically a timber frame all the way around, and because it was continuous all the way around, we felt that the only way of building it was in one circle, which was quite time consuming and delayed the process of getting to some of the finishes within the bedrooms. So again, through dialogue and through design development, we managed to introduce the concrete stair cores into the building. This had several benefits. The first one, probably the main one, was splitting the building into two halves. So we had effectively two stair cores opposite each other diagonally on the square, and then from that we could build the frame and starting in two places at once. So we had on site two gangs of timber frame erectors and following the rooms around. It also gave some added benefit, not major, but added benefit from a site logistics point of view. We had a staircase that was built before the frame was there, so getting access to all of the floors and all of the different parts of the buildings was all in place straight from the get-go. And also we managed to get that let with our groundwork contractor, so we really had one company on site from the groundworks all the way through to the timber frame starting in earnest on the project. Let's go the right way. The next thing, and probably I think overall the main thing that de-risked the project for us and allowed us to bring the programme down for the project and also the costs was the external wall construction. So the original design concept was timber all the way through from the inside right through to the outside with the cladding on the outside. We were concerned with this from a timing point of view and how long it would take. It really left the facade of the building on the critical path. So we had to get all the cladding done to get the building watertight to then start the fitting out of the bedrooms and the internal finishes. With the introduction of a lightweight steel frame on the outside, just as the inner leaf of the external wall, that allowed us to do that very quickly. We put cementitious board and VCL layer onto that, so we had the building watertight very quickly after the timber frame went up. That allowed us to get onto the internal finishes and the bedroom construction whilst protecting the time for us to take the time and effort on the facade of the building and the timber elements. So that change, although on a direct cost for cost basis didn't make a lot of difference, it allowed us to knock circa 10 weeks off of the programme and really give some certainty to us finishing the internal of the building, which became the critical path and allowed us a good 6 months on the external envelope of the facade of the building. The next thing I'll just take you through a little bit is the process that we went through with the French oak. So as Tom and Paul have already said, the French oak was from Railway Carriages in France. It arrived to us slightly different to that. They actually cut it in half for us because we managed to get 2 boards out of each one of those planks because of the thickness. But it came as a very rough, ready material, needed some work. So we decided that wouldn't be a very good idea to try and do that on the actual site itself and try and set up some sort of a prefabrication facility where we could process the wood, get it ready for using on site, and taking that time out of the critical path. So we had our own facility. We've got a yard just outside of Cambridge where we set up our own little joinery workshop purely for this job. The timber arrived at our yard at Caxton. We then treated the timber, did all the planing, all of the notching out of that timber, ready for installation on site. Whilst we were doing that, we started to look at the idea of using prefabrication as a way of speeding the project up even further on the site. So in addition to the treatment of the timber, we then started making prefabricated panels, and because we were so close, we were literally building the building, getting all the windows in, measuring the panels on site between the windows, having those panels then prefabricated at our yard, inside on proper joinery equipment, delivered to site straight onto the building. So the actual installation of the facade onto the building in the end was very quick. The other issue we had and were concerned with when we looked at the project initially was how we would procure the subcontract packages and elements of some of the the intricacy and different elements of the project, particularly the joinery. It was something that we were worried about, that money would end up being the driver for the job from a subcontract point of view. How much they could get done in a day, how much money they made, and those sorts of things. So we took the decision early on to use our own labour and manage the joinery elements ourselves. So we employed our own joiners, which we've now, since this project, we've kept on, and we've currently got 20 directly employed carpenters. And we used one of our managers whose background was a carpenter to actually manage that process all the way through. And it really allowed us to manage the quality and the attention to detail on site without having any pressures from a subcontractor needing to make financial gains on the project. Paul touched on it earlier, so once we'd been through, if you like, the initial design process and getting the project de-risked and down to where the budget needed to be, we then wanted to go another stage further to make sure that we understood what the building was going to take and what issues were going to come out when we actually started doing it. So to achieve that, we decided to build a mock-up. This is the mock-up we built. You can see just at the bottom it's on metal skids, and we still have this mock-up at our yard at Caxton now, and we use it to show to other clients some of the things that we've done. It allowed us to really solve lots and lots of the issues on site that we hadn't been able to pick up from the drawings. So the curvature of the building was an issue, and you can see the soffit. So on the building it goes from nothing on the corners to approximately 300 or 400 mil in the middle. Well, getting the metal cut at the exact size and shape to fit in was a concern, and was at one time looking like it was going to cost a lot of money with lathes and etc. But by building the mock-up, we realised that we've got enough tolerance at the back to actually just use straight rectangular pieces of metal and lose all of the curvature in the back behind the timber. So by building the mock-up on site, it became quite obvious how to fix a problem, and rather than having that problem when you've got a whole building to solve, we managed to do it on a smaller scale with the mock-up. This is again something that we've learnt from this project, and we now do as standard on all of our schemes, particularly in Cambridge, where we build these full-size mock-ups, and we've got a bit of a graveyard growing of them at our yard at Caxton. This is just the mock-up itself was a full section, a miniature section of the building. So not only did we build the outside face, we built a little mini room in the mock-up, and the back inner courtyard as well, just so that we'd work through all elements of the building. In addition to that, to make sure that we got the finishes and all of that properly done on the job, this is the sample room. This was constructed while we were still putting the roof on the building. So we had an area within one of the rooms within the building where we weatherproofed as a box, fitted it out, and again we managed to get the finishes through so that we could learn all the lessons and all the issues that go wrong, rather than having it across all of the rooms just on this one. And again, that was a real benefit to the project. So in summary, the project from our point of view at the start was quite challenging. It was done very much with us being kept at arm's length from a tender point of view. It was just sent out as very much as a cold tender. Once we'd worked our way through the tender and looked at and then gained some understanding of the project, as I said, we were quite concerned about how we were going to price it, and what risk we would have in it and the programs. By going through the process with Tom and Paul, particularly at the beginning of the project, we had about a 4-month period where we worked really closely together and going through all of these things. It completely de-risked the scheme from our point of view, and once we got onto site, it went really, really well. We were on site 66 weeks, but that included a 4-week shutdown for exam periods for the college. So it was 62 weeks, and with the slowing down and winding back up from the exam period, it was actually quite a tight programme. Our original tendered programme was in the mid-80 weeks, so just by going through some of these elements and making some of the changes without actually changing any of the fundamental design concepts of the building, we were able to get the time down and achieve the levels of quality that we knew that were really important to the client. Thank you very much.
Fantastic. Thank you so much to all three of you. Can I now invite you to join me on the panel here? for you, the audience, prepare your questions. We've got a roaming mic in the back. One thing I think I forgot to say at the start of the session is that actually the focus of the Timber Design Pioneers is really on the innovation, how it was achieved through collaboration of people. Very often it's actually people who've never worked together before. In this case, as we heard at the beginning, at least 2 of them have been working together for quite a long time. So I'm curious about how that panned out, but I would like to give you the opportunity to ask your questions first. Anyone? Yes, please.
Just Rupert Scott from Trada. Just delighted really about that, the principle of just making that mock-up and just how much got learnt just by making a sort of one-to-one or nearly one-to-one scale. I just wonder, how much did it cost as a sort of percentage of the project, perhaps, or in real pound note terms, and how much do you think it saved?
I think, is that hello? Oh yeah, there we go. The overall cost of the mock-up was just shy of £50,000. It was quite a big step for us to invest that money in the project, and I had to go through board approval to use the money. But it's really hard to gauge exactly how much it saved us, but I would put it easily over 100,000. We've done it on several jobs since, and every time we've done it, we always have a little bit of a, are we really going to spend that amount of money just building something that's going to sit in our yard when we're finished? But every time we do it, we always learn something, that even just one thing that always gets that value back for us on the project itself.
Yeah.
So I think we've got a yard of about 10 of them at the moment, and growing.
I mean, it seems, such an, in one sense, an obvious thing to do. If you were making a product, whether it's a car or a toaster or whatever, you'd spend a lot of time and money making a lot of prototypes. And yet in the building industry, we're always making these one-offs. And yet you're just describing the reality, which is that it sort of seems a bit odd to make a kind of a prototype or a mock-up. And yet it's a bit odd that we don't do it as a norm, really, isn't it? So glad to hear that it saved money, and by the sound of things, it probably enabled you to cut down from that 80 weeks to a sort of 50 or so weeks as well, which is an incalculable cost, really, isn't it? So, yeah.
I think I didn't say when we were talking, the other big thing that came out of it was the airtightness. So when we changed the in the structure of the outer wall with the Metsec and the cementitious board, there was quite a lot of detailing issues around that. And we actually did an air test on the mock-up at the start just to make sure that the facade overall achieved what we did. And when we did it about 3 times in the end, just to fine-tune the different detailing that we were building into the facade.
Further questions? Yes, please.
I'm wondering about how it's expected to weather and change over time. Do you have any ideas about what? I assume that the rail carriage boards are kind of pre-weathered and that they won't weather, but the fact that there are cantilevers means that there'll be differential weathering. The bits that are sheltered and the bits that are exposed, and those windows with those panels look like they'll weather differently as well. Do you have any idea how they're likely to weather?
Well, the project is now two and a bit years old. So one of the reasons for choosing the reused cladding was partly exactly for that reason, that oak, essentially, when it's new, is really great. When it's really aged, it's really great. And it has a kind of slightly patchy 10 to 20 years where, and actually to get this timber that was pre-aged meant that actually most of that change had happened beforehand. It's gone much more silvery since. So it was quite brownish when it first went up. And of course, all the fresh cuts were new timber. Now it's the darker parts have become grayer, and the kind of the yellowy parts have become grayer. So it's become slightly sort of a slightly grayer, more silvery thing. Then the new parts of timber. So there's the inside the cloister, and then there's the windows, doors, and so on, and so on. They're all sealed. So they do change, but much slower than the raw timber. But yes, the idea was to do a building that's somehow already old, kind of if that's not too much of a paradox.
Any further question in the audience right now? Yes, please.
Do you have a means of best practice sharing to make sure that we're all moving in the same direction on decarbonisation of the sector?
Formally, we don't. I'm not entirely sure I know how to answer that one. I mean, we were doing at the same time as this building, another building that was entirely made of concrete, right? Which we also did with Price Myers, with Paul and his team. And it was a big debate in the office when we were doing this almost all timber building, super high insulation, so very, very low U values, lightweight timber building. And then in London, we were doing this photographer's studio, which was all in situ concrete and block work, super high thermal mass, all basically passively ventilated and very high, very low U values as well. So they're all at the sort of 0.1 mark. And it was the same environmental engineers. And there was a big debate about which one is better, which one will last longer, which one will have the lower carbon, like whole life carbon footprint. Energy. So it's a really interesting kind of debate. Essentially, one is a working building and therefore has a very reliable environment. So you can kind of essentially have a very low energy, reliable environment because of the thermal mass. An accommodation building, you've got nearly 70 individuals all doing things at different times of day and night. So it needs to be very responsive. You know, it needs to be able to warm up very quickly when somebody comes back from college, or if they're staying in all day and writing or whatever. So I think that I'm not sure if I'm not sure if we come down in one way or another in terms of the decarbonising of the building industry. It's more trying to find ways which are appropriate to different contexts, different sites, different uses. That's, I suppose, the best I can answer.
There was another question in the front, please.
Thank you. The facade is absolutely beautiful for the next life of this material. And I'm just wondering if you put any thought into designing the rest of this to disassemble so the facade can have potentially a third life, and then the other material, the timber on the interior, a second life.
The timber on the building is we looked at different ways of fixing it. I've got to admit it wasn't for that driving force, but it's all been put on with screwed fixings rather than nailed, mainly because the wood was so hard we couldn't actually knock nails through it. But so you could easily take that facade off and reuse the timber again. The glulam frame itself again would be perfectly usable and decommissionable to be able to go back up again. And so there's a lot of that in there. I suppose the one element that's not that is the ground, the foundations and the slab and the stair cores being concrete. But, okay.
Further question? Yes, please.
I just wondered who found the railway carriages and the oak boards.
It was one of my colleagues in my office, a woman called Cécile David, who basically first went to Belgium. So Belgium has a much more developed material reuse industry than here. I mean, many more reuse products are certified and things like that for fire, for other things. And but once we were on that scent, we followed it, and it took us actually to France, to Brittany. And the main issue is quantity. So there's actually quite a lot in that building. So you can find amazing things and 300 square meters of it. Or, so suddenly we found this one lot. I think they had 8,000 square meters of it, and we needed 2,000? 2000.
About 2.
Yeah. So it was basically, right, we found a stock that's big enough that can do everything. And in fact, that was a couple of years, maybe a year before tender. So the client put down a deposit on it before, to lock it, because you can't go back and go for second. So it was quite risky. I mean, talking about de-risking it, I mean, it's quite risky from the client's perspective because there's no warranty on that stuff.
We ordered a bit extra.
Yeah, yeah. No.
We've still got about 200 metres of it, I think.
So for the extension. Yeah.
Another question? No? Well, then I can ask mine. I'm really curious about, so you've got a working relationship, you've been working on several projects together over the years, you've been even working on 2 different projects at the same time, but you came in new, didn't you? So how did that actually work out in such a complex project environment? How did you deal with that? How did you come together as a team to drive the innovation in there?
Do you want me to go? It was certainly at the start, from our point of view, we were coming in to an existing team, and we were giving bad news with the money and that side of it. And I think certainly at the start there wasn't, to be honest, a lot of trust between us from what we were going to do with it. And it really was a period of about, I think, 3 or 4 months after we were asked by the college to get involved, where we just worked through workshops. We were going down to Tom's office every week, and once I think Tom saw that we weren't trying to change the concept of the building and getting into things about how we could improve quality and all that kind of stuff, I think that then started opening up, and then we had a great working relationship then. So every time that any problem came up, either through that stage or later on, me and Tom often got together, just talked it through, came up with some ideas, and resolved it. And I think a lot of that was just about communication and just understanding, where we were all coming from.
Yes, I mean, I think it's about being prepared to kind of trust somebody, but you do have to kind of work at that when you don't know them before. But it's a really important thing for the building industry, because you don't build good buildings unless everybody is all one team from top to bottom. That's because that's the only way it works.
I mean, I would add to that. It was to Adam's kind of experience of it. So we'd been working with Paul since I think about 2005. This is the first time we did a project together for Raven Row in Spitalfields, and we've worked on many, I mean, not quite every project, but the vast majority of our work has been with Price & Myers. So that's a sort of a very established working relationship, which is incredibly productive, and we enjoy enormously. The project was going to be a traditional contract. So going through all the design stages, fully designed, and then go to tender, a kind of old school way. And right at the last minute, the college turned it to design and build, which I have to admit, I absolutely freaked out. I mean, I thought this is the end. This is the end of everything. This is the end of the civilized world as we know it. And it's so I was really worried about that process. And in fact, it was the first design build job we had ever done. Everything we've done before that was traditional. And I have to admit that I was, yes, I mean, as Adam remembers correctly, I was, very fearful that it would somehow, the project would just go off in another direction. But there were a couple of events that I think really cemented it. Firstly was when we did all the visits with contractors. We visited a project with Adam for Trinity College. It was actually a refurb project, where I think it was the only contractor, and they were quite big contractors, the sort of usual Cambridge ones. And I felt like with Adam, it was the only contractor where he talked more about the buildings than about the business, which is maybe a small thing, But actually, a lot of these big firms, they talk about supply chains, they talk about the business models, and Adam just talked about building. I thought, okay, well, he's really into building, and that's good. And the site in Trinity was amazing. The organisation, the skills all going on together, even bespoke site huts around the tree. You know, everything had been thought through. And so then we started having these workshops, design workshops, with Adam, Takesh, one of the guys in our office, myself, and then various subcontractors, depending on the kind of topic. And they were incredibly productive. And in the end, it felt like it was more old-fashioned than traditional, in the sense that we were all somehow all involved, everybody's sleeves were rolled up and just getting it done. And so it was a very kind of exciting, quite old-fashioned working relationship between architect, engineers, builders, all the subbies, all the specialists, and all of that. So it's quite unusual, I think, in that respect.
Anyone in the audience has got an additional question following on to this, or a new question popping up? No? What would you say is your lessons learned? What would you like to kind of recommend to your peers, basically, how to approach such a complex project in a team setup as you've experienced it, basically?
I think for me, it's what Tom just said. Talk about the building, not about contracts, supply chains, money, or that. If you fix the building part of it and sort that out so that it's easy to do, understood, everyone knows what they're doing, then the job always goes well. It's what we try to do all the time, is put the effort into that. It always sort of leads it, as far as I'm concerned.
I suppose going forward, I would say that this was the success of it was, I think, really in the interaction between all the parties. Like as soon as the guards were down and the trust was there, then and that's something which is quite difficult to set up, and I think it's even harder to maintain, because it is hard. These buildings are difficult to do, and it's sometimes easier to just turn around, point at somebody else rather than sort it out. And I think that somehow it was a very collaborative, very trusting, and there was a kind of appetite for risk as well, all the way from the client, all the way through the team. And I think that was also a very unusual space to be able to work in, one that is not totally scared of every bit of innovation, every risk.
And there wasn't any sort of criticism when anything went a little bit wrong from anywhere, was there? So as we were doing it, if we did make a bit of a mistake, whichever party that was, everyone else just rallied round to fix it, rather than it being, oh, you've got that wrong, and and that kind of attitude. It just made it so that everyone trusted each other.
Good client.
Yeah.
Really, really good client.
Yeah, it's the hot, and but it is the whole team, and it's the attitude, which does just have to leave aside the kind of contractual, issues, and not worry about, oh, is it D&B? Is it not D&B? Is that not? Can I get involved in kind of solving this? Because am I stepping outside where I should be in some responsibility kind of matrix situation? It's yes, we're a team. We're here to get it done, but it's not really easy to get that, because that's not the way our industry is set up most of the time.
So would you say the glue is really the shared interest and passion? Do you say bringing it down to the building rather than your own skills or your own commercial interests, kind of having a common objective?
Yeah, I think that's absolutely okay. Also, the other thing which I think, and I'm going to, I'm not being paid to pay compliments to SDC, but one of the very nice things about the company is how much direct labour is employed. So the guys on site, and mainly guys, but they work for SDC. And I remember walking past, and then one of the in the joinery being done inside the courtyard, there's a little inspection thing for the services, and all the boards aligned, all the oak had been absolutely perfectly done. And this guy just kind of tapped me, goes, "You're the architect, aren't you?" He said, "Look up." I just looked up and went, "Pretty tight, huh?" and he was very, very proud of the bit of work that he'd done. You know, and that was really, and it's not like, you know, we have worked with contractors who essentially their main business is managing other contracts. They're not builders. And that's kind of how a lot of the building industry is organized now. It's companies set up to essentially coordinate other people's work. Whereas I think with SDC, in that sense, although they're quite a big company, they're slightly old-fashioned builders. With, you know, you talked about the directly employed carpenters, but the fact that the cladding was not subcontracted, I think all of that made the thing very, everything was very close, essentially, and very direct.